The reason I've got this on is because I'm recording, and so I usually record the class, and then I post these after class, so you can refer back to them at your leisure, optionally, if you need to review them, okay? So I'll show you where those are going to get posted, but actually they're right here. This is the class, what's showing here is the class Blackboard page, and both the notes and the videos that I make will be under this button, so just find this Blackboard page for this class, right? If you have not, remember you can download the Blackboard app onto your phone and just go to this class notes and videos link, and they'll all be posted there, both the notes that we take and then the videos of the class. But it usually takes me like usually what wouldn't be to this evening or later before I can get the video posted, because it has to be processed first, and I have to upload it to YouTube. They're just YouTube videos. Anyway, also you can see on the class Blackboard page is the class syllabus, right? And we're going to talk about that in just a second. So we're passing that out, but this is the Blackboard page. We won't really be referring to the Blackboard page all that much, but we will sometimes. The main online site portal for this class will be the homework site, not the Blackboard, and those are different. So I'll talk about that later also. Okay, I'm going to get you to move right there beside this gentleman up there. Yeah. Okay. Sorry. All right, but anyway, I had to have something to show here to start with. So there's the Blackboard page. So the copy of the syllabus you have is a little bit out of date in a couple of places, but the most recent version of the syllabus there is posted under this link. You can find the most recent version of the syllabus, but that printed one is okay. I mean, it's okay. Just to refer to. Other things that'll be here eventually on the Blackboard page are sample tests when we get ready for having a test, but that's a little time in the future here. But I always post sample tests for those, and then after we've had a test, there'll be test answers there also on the Blackboard page. Ooh, I forgot to introduce myself. So my name is Dr. Waller, okay, and you should be here for college algebra. Is everyone here for college algebra? All right, so yeah, we've just got 2 people left to go who are on the roster, so hopefully they will show up, or maybe they got dropped for some reason. But in any event, this is college algebra. For many of you, this is your first college math class, and so I'm very excited to have the opportunity to teach you your first college math class, okay? I hope it will be a really positive experience for you. If you're in college algebra, that means you probably need to take more math classes, right? So I want to prepare you as best I can for those future math classes and put you on your way to having a successful math experience in college. So I'm going to do my best to do that. This class is it's algebra, right? But it's algebra at the college level. So we're going to try to take your prior knowledge of algebra, and all of you have prior knowledge of algebra that you can use and relate to, and we're going to try to elevate that to the college level. Okay, so we're going to be looking at just the usual objects that one studies in an algebra class, right? Numbers and equations, for example, right? Okay, mathematical expressions, and we're going to try to elevate our knowledge of that to the college level that you'll have that will be necessary for you to excel in your future math courses, right? Or also occasionally in your disciplines, whatever your major may be, when they use math, right? Okay. So we're going to learn some concepts and some mathematical objects that are new to you in the class, and then functions and relations are really going to be an important topic in the class. We're going to talk about those a lot, and we're going to apply those to studying algebraic objects that you're familiar with, like equations, okay? So the class will, again, be an algebra class. So a lot of the things that we do in the class will be really familiar to you. Now, there will also be applying our new knowledge, though, to study some problems that you may not be as familiar with, okay? Maybe you are, but probably not as familiar from your prior algebra experience. So one of the things we really want to do in the class is apply our new knowledge to analyze data, okay, and to study data and be able to draw conclusions from data. So that may be a little bit new to you, okay, but it really is a very algebraic topic, as it turns out, okay, and it's a skill that's really important in the workplace, today's workplace. So we're sort of looking ahead here and trying to, even in this very first college class that you're in, right, to try to prepare you for eventually for your workforce experience, right? So I'm trying to give you some skills that will be beneficial to you when you graduate and get a job, right? Or maybe go on to graduate school, okay? So that's what we're going to be. That's really what we're going to be studying in the class, and we're also going to be maybe trying to treat our study of mathematics in this class a little bit more rigorously than you may have in past math classes. So we really want to sort of maybe dive a little bit more deeper into maybe conceptually how the mathematics is working and build up our mathematical reasoning and our mathematical logic abilities as well, okay? So we need to start training you along those lines, okay? So the class may feel a little bit more theoretical than your prior math classes, but don't worry, we're going to take it one step at a time, okay? I'm not going to get ahead of you, right, okay? And we're going to build up your knowledge incrementally, piece by piece, okay? So you'll be prepared for everything that we're going to do based on your past experience. We may just be taking that a little bit further or a little bit deeper, okay? I don't want to spend too much time going over the syllabus because that is a long syllabus, right? So I have a lot of information in there, but I do need to say just a few things there about how the class is going to work, just so that we can say that we have we've covered all of that, right? Okay. So again, my name is Dr. Waller, right? Okay. You can see, of course, this is when we meet, right? So you're here in the right place. So I assume you know that already. We've been meeting here all semester as far as I know, all the way through the final exam, right? So the final exam will be held in this classroom. My office is not in this building. It's in the one main building, the big building up on the hill. Am I pointing the right direction? Maybe there, okay? And my office is South 718, so on the south side of that building, 718. That's where you can find me. There are my official posted office hours, but if you can find me at other times, that's fine, okay? We can always meet whenever I'm free, or you can make an appointment. You can call me at this phone number. That's my office phone number, but it's better to email me. Okay? So I think the safest way to get in touch with me is most reliable way maybe to get in touch with me is to email me there right at that email address. If you have any questions, or if you want to make an appointment to see me, or if you're asking me if I'm in the office or something, there's where you can find me. So we already talked about what the course was about, right? Okay, and here are the official learning outcomes for the class. I have to post those because that's required by law, but I'm not going to go one by one through those learning outcomes because they're not going to make much sense to you at this point. But those are the things you're going to learn about in the class. But I already explained to you what the big picture of what the class is about is going to be. Okay. Now, the class is going to work very much like a standard college level math class in terms of grading and what we do. So we're going to have, 3 tests, and those 3 regular tests, and those count as like about half of your grade. We're going to have homework, right? That will be done online. I'll try to explain that a little bit better in a few minutes here. So you will have homework that you do, right, just like you always would have in a math class. And then, of course, we have a final exam, okay, at the end of the semester, which everyone's going to take, all right? So, and that counts about a third of your grade. Homework is about whatever the percentage there is listed there. It's about the same as a midterm test. Okay, so those are the real big components of your grade. And at the end of the semester, we just compute an average and then assign letter grade based on that, right? Based on the usual college scale. So 90 to 100 would be an A, and 80 to 89 is a B, and 70 to 79 is a C, and then we won't talk about lower scores than that, all right? So because you're aiming for a 70, right? So we'll just assume you're somewhere there between 70 and 100, and that's how the letter grades are going to be done. Okay, that's about it. Okay, in terms of class policies, except for the homework, which is a really big part of the class, but I have to explain a little bit better to you how the homework works and how to get registered for the homework site. Okay, and I'll do that in just a second. Okay. Oh, I want to introduce you to a very important person here, or maybe she'll introduce herself. We have the luxury of having a supplemental instructor for this class. This is Taylor. Taylor, you want to explain what you do?
Yeah, hi, I'm Taylor. So I'm going to be your supplemental instructor leader for this semester. If you don't know about SI, or as we call it, supplemental instruction, SI, generally it's a program that targets historically difficult classes, and our goal is to help y'all pass and kind of enhance the learning experience as opposed to like normal tutoring. For this class, I'll only be in class, and since it's an extended college algebra course, I'm sure there's going to be time like towards the end you'll be working on homework or what it might be, and I'll be walking around to kind of help you. That being said, there will be sessions like held throughout the week, throughout the whole semester by other people, not by me, that you can attend if you need additional help outside of class. And I'll be handing out a schedule maybe on Wednesday, maybe not, maybe on Monday, that has all those listed times that you can attend. Other than that, I'll just be in class.
Yeah. So Taylor's our assistant, so she's going to be helping me with various things, and in particular, when we're doing class activities, Taylor's going to be with me, helping you get through the class activities as well. Okay. So that's a real nice benefit of this particular section. There are lots of other places, though, Taylor mentioned on campus outside of class where you can get help, okay? And I'm going to mention those from time to time, okay, when the opportunity presents itself, right? Maybe next time I'll start talking about where the resources are for getting help outside of class, okay? Because we'll already start probably by next time our first homework assignment, so you may already have an opportunity to ask for help outside of class. But Taylor's going to be helping us in class. Now, as Taylor mentioned, this class is a little bit longer than a standard college algebra or a standard college class, which usually meets for an hour and 15 minutes. We're going to meet for an hour and 45 minutes instead, so we have a little bit extra time, 30 minutes. So we're going to use that time, hopefully, for working in class here and to better prepare you for your homeworks and for your tests, okay? So we want to take advantage of that extra time to give you an even better experience here in college algebra, okay? So that's the purpose of the extra time. I think you'll find it very beneficial. It typically shows up in grades as being very beneficial, okay? So if you're interested in having a higher grade, then you're in a good place, okay? So we do have to meet a little bit longer, okay? But it's going to be worth the price there, I think, okay, of that time. Do y'all have questions that y'all want to ask me about stuff? I'm sure there are things I forgot to say, and they'll come to me, through the semester. One thing I did want to say is in the back of the syllabus, there is a calendar for the class. It's not a super long calendar. It's not super detailed. But if you go there to whatever page that is, page 8, Is it already that? Yeah, all right. There is just sort of the brief outline of where we're going to be. And probably the first thing that's really important to you there is when the first midterm test is. So that is September 25th. So all the test dates are listed there, okay? So you don't really have to pay that much attention to what sections we're doing before the test, but the first one is coming up on September 25th. That's a Wednesday, okay? So that'll be our first test, right, on that particular day. One thing also I noticed here that I forgot to mention before are some of the class policies, okay? There are not many of them, but I will be taking attendance, not starting today, but maybe next time or the following Monday, next Monday, I will take attendance. So we do have an attendance policy in the class. So when I start taking attendance, I'll tell you how the attendance policy works, all right? But you can read about it in the syllabus. So there is an attendance policy. And I don't have many class restrictions, many class policies, but there are a few, and one of which has to do with cell phones. Now, in this class, we may use cell phones more than in other classes, all right? But normally, I don't like cell phones out, okay? But we may have an opportunity to use those, especially during our extra time when we're doing activities, okay? So in general, don't use your cell phones. You may be using that for a calculator, though. That may be your primary calculator, your cell phone. I use it all the time as a calculator. But I'd like you to have another calculator, okay, a scientific calculator for the class. That's all you need is a scientific calculator. You don't need a graphing calculator. If you have that, that's great. You can use it. But you don't need that. You just need a scientific calculator, and that's one that has a log or an ln key on it. So look for log or ln key, okay? So if you don't have access to a calculator, you can borrow one. But if you don't have access to one, yeah, that one's great. Okay, that one's fine. They're super cheap now. You can actually buy them for like $2 at a dollar store if you find one there. Okay, look around at dollar stores. That's all you need in terms of technology, right? Okay, we will be using tech in the course for doing lots of things, but it'll all be computer-based, free stuff, right? So you don't have to purchase a calculator, all right, like that. Okay, let's see. Taylor, did you give them index cards? All right. So no, any more questions there? In particular, something I forgot to say. I'm sure lots of other things will come up, as already mentioned, that I didn't say. All right, so let's get past all that boring syllabus stuff. And here's the first thing we're going to do. So this is not really a math activity, okay? But this is for us to, for me to get to know you. It's going to take me a little while to get to know you. Taylor's probably going to get to know you faster. But it'll take her some time as well. So on this card, okay, of course you want your classmates to get to know you as well, right? So on the bigger card, the bigger index card, everyone got a bigger index card, right? Not the small one. I want you to fold that from left to right. That's called hamburger style. So I want you to fold it hamburger style. This way, the long way is hot dog style. That makes more sense. I don't know why they call this hamburger style. Anyway, I want you to fold it this way, hamburger style, so that you make a tent, right? Okay? So you're going to make a tent. So I'm going to fold yours for you. Sorry. All right. And I don't care if the clear side is what you write on or the line side is what you write on. That's all right. But anyway, you're going to have a tent like this. And I want you to put some information on the tent, okay? And we're going to use these until we get to know each other a little bit, okay? Or until we lose the cards, because that'll happen eventually too, all right? But hopefully that'll be after we have learned each other's names, right? So I want you to put this information on here for me in the four corners, right? And in the middle, of course, that's going to be your name, right? Okay, right there in the middle of your name tent. So this is really just a name tent. kind of an information tent. So put your name. Be sure to put your last name as well, though. But for your first name, I want you to put whatever name you want me to call you, whatever name you go by, right? Okay. So if it's your, if it's your official first name, Aloysius, for instance, then put that. But if you want to go by Al, then put Al. Okay. All right. And then, but I need your last name too. All right. On there. And then in the top, what side is that? Left-hand corner, I want you to put whatever your major is, okay? Or what you're thinking about as a major, what your interest is, if you haven't formally declared a major yet. On the right-hand side at the top, your favorite book, movie, or song. You don't have to have all three, so whatever comes to mind as your favorite book or movie or song. Could be whatever song you just heard on the radio, while you were coming to school, right? Okay, if that's on your mind. So favorite book, movie, or song. And then in the bottom right-hand corner, whatever your favorite food is, right? So I usually get almost all the same answers here, okay? But whatever your favorite food is, all right? And then, this is the hard one. You have to draw for me your favorite pastime, okay? So what you do for a leisure or fun, right? Okay, see if you can draw a picture that tells that, okay? I'm terrible at this, so I can never get this right, all right? Okay, so whatever your favorite pastime is, now keep it clean for me though, okay? All right, so no lewd pictures there on these name tents because we got to show these all semester, all right? So, yeah, so like this, right? Okay, I'll let you work on this side, right? Like this, and then, because we're going to make a tent out of it, right? And so do that on. Did everybody understand how we're doing this? Yeah? Okay, right? Okay, because I have to have a tent, so I need all the information on one side of the tent, and try to draw those things for me. There you go. Okay. Great. All right. So last name too, though, for me, right? All right. Now, on the other card, the smaller index card, right? On one side of that smaller index card, I want you to put your name again. Okay. So same name as you put on your index card, though, right? But that's all that goes on the smaller card is just your name. Nothing else on there, right? Okay. So just recopy that name. That's fine. Yeah, this is correct. Yeah. Okay. So on this, then, you did this already on this. Well, it doesn't matter. All right. So on this one, just recopy your name. I just need your name, but I need your last name on here too. Yeah. So yeah, be sure to put your last name. You can make it really small. I'm going to go by your first name, but I also need that last name on your card. Okay. So when you're done there, I want you to put your name tent up for me in front of yourself, right? Okay, so I can see who everyone is. Did you? Okay. All right, Mr. Kelly, we gotta fix this for you. All right. So yeah. All right. So you fold it like this, and then all that information will go here, right? Because I need a tent. All right. So this will be facing, right? So name in the middle, right there. Yeah, exactly like that. Right? Yeah. Sorry. Okay. All right. Yeah, because we're gonna make a tent out of it. Yeah. All right. Are we getting there? Well, I thought you had written words, but that's really a picture. Yeah. Okay. All right, Ben. Yeah, just your name, just the same name you put on that tent on the other card, because I'm going to collect those, but the tent we're going to leave in front of you, right? Like a tent. So that I can, well, this is really okay. Did you draw a picture of that, though? Okay, all right, well, that's good. So draw that base. Well, you can use that. It's not the end of the world. I'm going to give you another smaller card, though, so. If I can find, oh no, Taylor's got them. Are we almost to do with those. Oh, put them up front. Yeah, there they are. Yeah, just your name on that one. All right, so let me have the one with your name on it. So I can collect those when I need to refer to you. Put your, is it Mitchell Kelly? Montel. Okay, Montel. Just put Montel Kelly right there. Yeah. Thank you, thank you. I know you'll have to do things like this a lot in all your classes on the first day. It gets tedious. But that's because at UHD, we want to know your name. This is fine. Oh. Where's Furman? Furman. Okay. All right. Let me give you another card for this one. All right. Just so all the cards that I have will be the same size. Otherwise, I end up screwing things up. All right, Furman. And you get a free index card there with your name on it. All right. So, got everybody's smaller card? All right, great. Okay, let's get to know a few people in the class. Now, I'm going to use these index cards throughout the semester. All right, so, but here's our first chance. All right, Montel, I want you to pick a card, any card. If you pick your own, that will be funny. All right, nope. Okay, now we got Furman, who we're just talking to. All right, stand up, Furman. You're just going to introduce yourself to the class, all right? So basically, you're just going to say what you put on that card, right? What's your name? What is your name? All right, you said that beautifully. All right, I'll do the best I can with that. Okay, all right. And what is your major? General business, okay. All right, so are there other business majors in the class? Oh, great, that's good. All right, and any favorite book, movie, or song?
Game of Thrones is my favorite book.
Game of Thrones, okay, all right. So that one at least I'm familiar with. Usually people say things that I have no idea what they're talking about, okay. What pastime did you draw there for us? Wait, let's see if okay, I think I can figure, can y'all figure that one out? Oh, sleeping. All right. So, Furman, is that really true, or are you just, that's easy to draw? Okay. All right. And, Furman, what's your favorite food? Pizza. Yeah, okay. That's always a top 3 choice there. All right. Who doesn't like pizza? Ooh, thanks, Furman. See, now your card's going to the bottom of the pile, so aren't you lucky, right? Okay. So, so now you get a little bit of a break here until I come back to you, maybe. All right, let's let Taylor pick someone else for us. So, Taylor, I'm going to come around there and let you draw a card at random. We're just getting ready to know people. This is Furman, okay? All right, Eduardo, if I'm saying that right, where's Eduardo? Hey, Eduardo, stand up and say your name for us. So you can probably say it beautifully there like Furman did his. What? Ah, see, perfect. All right, okay. Management. All right, so there's another business major. Excellent. Okay. Right here in Shea, just the perfect place for a business major. What?
My favorite genre of music is country.
Country. I wouldn't have guessed that, but okay. All right. And what's your favorite pastime? Oh, wait, let's see. Oh, okay. All right. Well, we could have figured that out anyway. Can y'all see that very well? Okay. Sports, yes. All right, okay. Sports, okay. And what's your favorite food? Mexican food. All right. Okay. Another top 3. All right. We get that one a lot. Okay. All right. Eduardo. Oops. Nope. No, you get to keep that one and put that one back up. I get to put this one up. Eduardo, we'll have you pick someone else here for us to get to know. All right. All right. So we need to get some women, but this is Joshua. Where's Joshua? Oh, right there. Okay. All right. Stand up, Joshua. Tell us about yourself.
My name is Joshua. My favorite book is The Percy Jackson.
Okay. Percy. So I know that one too, right? Okay, so that's good. What's your major?
Accounting.
Accounting. Okay. All right. So there's a person that's aiming for a job. They're accounting. All right. What's your favorite food, Joshua? What?
Taco.
Tacos. Okay. Yeah, sure. Right. And what's your favorite pastime? Food. All right. Eating. Okay. All right. Excellent. All right. Okay. Great. All right. Let's try one more. I'm going to cheat. I'm going to pick one. Like I said, we've got to get some. All right. So, Juliana, we got to get some girls here. Juliana, stand up for us and tell us about yourself. What's your name first? Juliana Benitez? Okay, all right, okay. That one's a little bit easier to pronounce then. All right, so.
My major is general business.
General business, wow, so many business majors, okay. And
I really like Endgame.
what?
Endgame, the movie.
Endgame?
Yeah.
What movie is that?
Marvel.
Oh, the Avengers Endgame. Oh, okay. I just saw that on the plane this summer. Wow, that was long. I thought that was never going to end. I was like, wow, okay, it's over. Let's, all right, what's your favorite pastime? Oh, I'm sorry, I forgot to look at your picture. Is that a bicycle?
Yeah.
Yay! Okay, all right. It's either a bicycle or some strange sort of scooter there. All right, so bicycle. All right, and so you bicycle a lot?
Yeah, I like bike riding.
Oh, great. Okay, and what's your favorite food?
Sushi.
Sushi. Okay, bicycling and sushi. All right. All right. Okay, thanks. As we get the chance through the semester, we're going to meet more of you, all right, because I get to call on you a lot this semester, okay? And so as we are hearing from people in the class for the first time, we'll get them to introduce themselves and talk about themselves. Okay. So keep that name tent. When you leave, you do not have to pick up your name tent. We'll pick that up for you. Okay. So just leave that on your desk, and then we'll pass it out again next time as well. Okay. All right. Well, I can't think of any other sort of activity to kill any time here, so we're going to have to go ahead and start right with the math, right? So we're going to do some of our math today, all right? And but what I want to do is I need to activate some of your prior knowledge here about math and algebra, okay, so that we will loosen up your neurons a little bit before we start talking about something that might be new to you, okay? So we're going to do a little bit of what I call recall practice here, okay? And this is a good way of getting you warmed up to learn new material, okay? But also give us a chance to review some important things that you're going to need for the class that I'm not going to, talk about explicitly, right, like it's new to you, okay? It's stuff that we're just reviewing. All right, so what I want you to do is turn to the person to your left or your right. I call that your shoulder partner, all right? And what I would like you to do is write down on a piece of paper. Do you need some paper? Because I've got some blank paper if you need some blank paper here, okay, that you can write on. So y'all can pass these out as you need them, okay? But if you've got a notebook, that's fine, all right? You can write down, all right? So the person sitting next to you, right, okay? So you know who your natural shoulder partner is. Everybody's got to have a partner, so don't exclude anyone there. If we've got an odd number right here, so you can talk to them. Why don't you scoot over one seat for me there, okay? What is your name? Put your chin up so I can see that. What? Danny. All right, so just move over one chair there, okay? And so y'all can be shoulder partners, all right? Although normally I'm thinking of two, right? Okay, so here's what I want you to do. I want you to write down an explanation. It's got to be in words now, okay, of what how positive whole numbers, exponents work, okay? Positive whole number powers, like 2 to the 5th power x cubed, or there we have a plus b squared, okay? So what do positive whole number powers mean, okay? Right? When you encounter that in a mathematical expression, like those three expressions as examples, right? What is that telling you? Okay, so what's the meaning of that? A positive whole number power. So this is the power, right? This is the power. Okay, that's the power. What does that mean? Okay, all right. So just see if you can write down an explanation for that. Okay, in a few words. We'll take a couple of minutes here to do this, but you can talk about it with your partner now, right? Okay, so talk about it with your partner. You just want one explanation per group. Okay, so just talk about it with your partner. What does that positive whole number power mean? What is that telling you to do? How does that work? Okay, so
Are you asking us what's the meaning behind the numbers, integers, and such in general, or just
anytime you have a positive whole number, 1, 2, 3, 4, written as a power, what is that telling you?
Multiply by the number.
Uh,
But
Okay, so write that down. All right. Okay. Yeah. Right. Okay. So y'all are saying it. Just write down what you're saying to me. Okay. All right. Questions about that? Y'all think y'all have the right, or is not the right?
we're supposed to explain each one of those?
No. Just in general. What? Yeah. Those are just examples. So not each one of them. Just in general, when you have a positive whole number power. So that would be 1, 2, 3, 4, 5. Those are etc. Those are positive whole numbers. You have that written as a power. What is that telling you to do? What does that mean? Okay. How do you interpret that in the expression? Okay. Are y'all writing something down there? Right. Okay. In words. Try to get the same explanation. Did y'all write something down there? Yeah, thinking about it. Okay. Right. So try to remember, what does 2 to the 5th mean?
multiply 2 by itself 5 times?
Okay, so right, that's what I mean by writing something down, right? So you're saying it, just put it down in words, okay? Yeah. Yeah, so whatever you're verbalizing there, just put that down in words. Because you probably got it right. Did everyone write something down? I got an explanation written down. Did y'all write something down? Okay, in words, though, right? Okay, so yeah, be sure you explain it in words, all right? So say in words sort of what you were doing there, okay? I know it's a math class, but the words are really important. That effort to verbalize, put things in words really helps a lot. You wouldn't think so, but it does. Did y'all write something? Okay, I'm going to call on someone now, all right? Taylor, we'll let you pick someone here. Okay. So I'm going to call on someone, and then you're going to get to read back you and your partner's definition to the class. Okay. And we'll see if we agree with that or can understand that. Okay. Oh, can't use that one. All right, these last. Yeah, that was my fault. Jennifer. You're Jennifer. Okay. All right. So let's read back what y'all wrote. But would you stand up first, though?
Yeah.
Oh, before you say it, tell us, since we don't know you yet, right? Tell us something about yourself there.
Jennifer.
Mm-hmm.
My major is mathematics.
Wow. Okay. So we're expecting a really great explanation here, Jennifer. Right? Okay. Not to put any pressure on you, but go ahead.
Okay. Yeah. I didn't put a movie. I put a show that I like.
Mm-hmm.
I'm watching Grey's Anatomy.
Grey's Anatomy. Okay. A lot of people watch that. So.
Yeah.
And what is your favorite food?
Oh, I put tacos.
Tacos. Okay. So we had 2 for tacos there. And what was that picture?
It's a boat. I was in drill team.
Oh, you were in drill team. Oh, okay. So that was your. All right. Excellent.
Yeah.
Okay. All right, Jennifer. Now on to the math here. So what did you say?
I put that the whole number, which is 2, is going to be multiplied by the power, which is 5. So it would be basically 2 times 2 times 2 times 2 times 2.
Oh, so read back what you said, though.
The whole number is going to be multiplied by the power, which is 5.
Okay. Is that what she meant to say? Because she explained it differently. She said 2 was going to be multiplied by 5, but when you multiply 2 times 5, you get 10, right? Okay. But that's not the result of.
I had a word in it.
Oh, all right. So, but what were you thinking if you were going to simplify 2 raised to the 5 power on paper? What would you write down?
2 times 2 times 2, 5 times.
Oh, all right. So 2 times 2 times 2 times 2 times 2, right? Okay. Which is not the same as 2 times 5, right? Okay. By the way, 2 times 5 is 2 plus 2 plus 2 plus 2 plus 2, right? Okay. But you said 2 times 2 times 2 times 2 times 2, right? Okay. Which is a little bit different thing, correct? Actually, quite a bit different thing, right? Okay. So you are right. 2 to the 5th power is 2 times 2 times 2 times 2 times 2, but you didn't quite write that down what you meant, right? Okay. Let's see if we can get another group which has maybe they said it differently, maybe a little bit better way. Okay. You want to pick one here? All right. So Chris. Where's Chris? Hey, Chris, what did y'all write? Did y'all say something different? Okay, so, and I think that's more like what she explained, right? Okay, multiply the base by itself, right? Okay, and then the number of times you do that is whatever the power is, right? Is that what everyone understands as a whole number power? Okay, so for instance, if we wanted to simplify 2 to the 5th power, then we would write down multiply 2 times itself, right? 5 times. So this is 2 times 2 times 2 times 2 times 2, right? Okay. Of course, x cubed then would be what? What now? Yeah, x cubed would be x times x times x, right? Okay. And then what about a plus b squared? What would that be? Oh, someone said a squared plus b squared. Is that right? Yeah, so apply your same reasoning here to a plus b to the 2nd power. That means what? A plus b what? Times a plus b, right? Okay. Yeah, times a plus b, right? You're going to multiply it there times itself, right? And when you expand that product, by the way, what do you get? You get a squared. You do get a times a, okay? You get b times b, so you do get b squared. But what else do you get? Yeah, you get a times b twice, right? Okay? So you also get a times b and then another a times b. So notice you don't quite get just a squared plus b squared, right? Okay, so this is not quite correct. Here's the right way of simplifying a plus b squared. A plus b, a times b plus a times b is 2a times b, right? Okay. All right, so exactly. All right, so y'all understand that pretty well, right? Okay, what that power is telling you, if it's a whole number, right, a positive whole number, that just tells you how many times you're going to use the base as a factor. Okay, how many times you're going to use the base as a factor. Factor are quantities that are multiplied together, right? So that positive whole number tells you you're going to use a 5 here tells you you're going to use 2 as a factor 5 times, or this 3 tells you you're going to use x as a factor 3 times, right? Or this 2 tells you you're going to use a plus b as a factor twice, okay? All right. Did anyone just completely, even if you didn't verbalize it, did anybody just completely not remember that at all? Okay. Guess I don't want to ask you to raise your hand when you're all right, okay? I think most people probably understood that pretty well, right? Okay? Okay. All right, now let's, we're going to up the difficulty level a little bit though, right? Okay? Oh, so let me write down my first rule here for simplifying exponents, which is if m is a positive whole number, right? Okay? If that power is a positive whole number, you're going to use the base as a factor m times. So you get m factors of a. But this is m has to be a positive whole number. So everyone understood that, I think, already. Okay. All right. Let's try this again now, okay? So maybe this one also is pretty easy as well, all right? So 0 is not a positive whole number, okay, right? Because it's not positive. 0 is not positive, by the way, all right? The number 0 is not positive. It's not negative either. 0 does not have a sign, okay? So it's between negative and positive numbers, but 0 does not have a sign, okay? So not a positive whole number, but we can still raise quantities to the 0th power. That's allowed in algebra, right? Okay, what does that mean? All right, so what does it mean to raise a base to the 0th power? So see again with your partner if you can recall and write that down for me. All right. So see, now this is different, right? Okay, this is different. What does it mean to raise a base to the 0th power? Because this is permitted, okay? So this is allowed. What does that mean? Can you write that down in words? Does that make any sense at all? Joshua, does that make any sense? Okay, right. What would that mean? Or can you recall, try to dig back in your memory there, because you have seen this before. Try to dig back in your memory and see if you can remember what that means. No, you don't have to explain why. Okay, right. Yeah, that's a tough one. But so, yeah, if you can't explain why, just write down in words just what it means, okay? So of course, the y would always be great, y, but if you don't know the y, at least do you know how to do it correctly, right? Okay, even if you don't know why that's the case. All right. Did y'all write something down? Did you write something? So,
nothing will happen. It will just stay zero.
what will stay zero though? When you say it will stay zero. So 5 to the 0th power would simplify to, that would be just 0, okay? All right. Did everyone write something down? Because I'm going to call a group here, okay? So you need to have something to put down, all right? For what you think that means, okay? All right, let me dig in here. Everyone got something written down? They're going to get harder and harder, too. Okay, so, all right. Who is this? Gio? Cleo? Melendrez is the last name. What? See, this is why we need to introduce ourselves. So, stand up there and say your name and tell us about yourself.
My name is Giovanni Melendrez from Northside.
And you go by Gio, right? Is that all right? So that's Gio. Okay, all right. So Gio, what is your major?
General business.
General business. Okay. Another one of the business group here. What's your favorite book, movie, or song, Gio?
All Dogs Go to Heaven.
All Dogs Go to Heaven. Okay. All right. And favorite food?
Tacos.
Tacos again. Wow. Oh, we're scoring big on tacos. What is your? Is that your?
It's a TV.
Oh, that's a TV. Oh, that's a TV.
I don't know how to like trace no car. So.
Okay, all right. So TV, all right. All right, Gio. So tell us now what y'all wrote down. You and your partner. What is your partner's name? Uni. Okay. What did y'all write for? What it means to raise a base to the 0th power.
We didn't really conversate, but I put like the base with an exponent for 0. Like it just sums up to 0.
Oh, so this is 5 to the 0th power is just going to be 0? Okay. All right. So y to the 0th power also 0? Yeah. Okay. And this one is 0 also? Okay. All right. So you're thinking that 5 to the 0th power is similar to 0 times 5, right? Which is definitely 0. I think there's no dispute about that, right? Okay. But remember, in that prior example, someone said 2 to the 5th power. She had it right, but she said it wrong. What she said was, this is 5 times 2. Which is not correct, right? Okay, 2 to the 5th power is not 5 times 2, right? Okay, what that really was, you know, as we talked about, right? That means use 2 as a factor 5 times, right? Okay, so Gio, see, that may give you pause here, right? Because 2 to the 5th power was not 5 times 2, but you're saying 5 to the 0th power is the same as 0 times 5. So see, that's a little bit suspicious because this was not correct, right? So that's casting doubt for me on whether this is correct or not, okay? Right? Does anybody have a different explanation for what it means to raise a number to the 0th power? Yeah, what did y'all have there?
You know, anytime you raise, let me see what he wrote, number to the 0th power, it'll be the same number. So, like, for example, 5 to the 0th power would just be 5.
5 to the 0th power would just be 5, okay? All right, so there's another possibility that 5 to the 0th power is 5, okay? But I'm worried about that one, okay, because that is the same as 5 to the 1st power, right? So I think we're all agreed. Is it Amber? Amber, I think you probably agree that 5 to the 1st power definitely 5, right? Okay. So, but you're saying 5 to the 0th power also is 5. So I'm a little bit suspicious because why would 5 to the 0th power be the same as 5 to the 1st power, right? Because these are different powers, right? Now maybe it is, okay, but that makes me wonder about that, right? Okay, about whether that's the case or not. Okay, all right. Um, Anybody else try something different? Julian or Juliana? Okay. Ah, there we go. Okay, yeah, all right. Does that ring a bell? Okay, yeah, all right. Everything to the power of 0 is equal to 1. Yeah, okay. By definition, um, any quantity, any base raised to the 0th power is just going to turn out to be 1. That's one of the easiest exponents to remember, okay, is a base to the 0th power is going to always be 1, okay? But now, why that's the case, there's definitely reasons why this should be the case, okay, which I'm not going to explain here, and they're hard to remember, why raising a quantity to the 0th power should be 1, okay? There are algebraic reasons for that, but they're kind of obscure. So you're just going to have to basically memorize this rule. When you raise a base to the 0th power, you're going to get 1. All right, okay. There is an exception to that. I'll show you here right now, okay. All right, so here's our second rule for simplifying exponents. So we already have the rule right for when you have a positive whole number exponent. That's the easy one, okay. That's one that's easy to remember. Here is one that's not easy to remember, but you have to memorize it. A base to the 0th power is going to be 1, okay? The one exception is the base cannot be 0, okay? The base cannot be 0. 0 to the 0th power is not defined. That is not a number, all right? Okay, so we cannot raise the base 0 to the 0th power. We try to do this all the time, by the way. It shows up all the time in math, okay? Right? Taylor, we try to do this in calculus a lot, okay? And it causes all sorts of issues, all right? So, so you have to avoid raising 0 to the 0th power. But otherwise, any other number to the 0th power, that's just going to be 1, okay? All right, so hopefully you'll recall that, because I know you've learned that fact before, all right? Hopefully the next time you need to do that, you can remember that again, all right? Now I'm going to make it harder. All right, what in the world does this mean? Okay, so we talked about positive whole number powers, and we talked about 0, but what about negative whole number powers? Okay, negative whole number powers. So what if you want to raise 2 to the minus 5 power instead of 2 to the 5th power, or x to the minus 3 power instead of x to the 3rd power, positive 3 power? Or suppose you want to take a plus b and raise it to the minus 1 power, right? That's all permitted, okay? What does that mean, okay? So can you recall from your prior training in algebra, you're going to have to squint your eyes and grit your teeth, right, okay? And try to dig back there. Can you remember what it means to raise a number to a negative whole number power, okay? And try to write something down in words, okay? What does that mean? Got it. Okay, all right. That sounds very confident there. All right. Y'all recall anything about that? Have you ever seen that before? That's never saw that? Yeah, okay. You don't know how to put that into words? Okay. Well, see. Tell me what you're thinking. Mm-hmm.
is 1/2.
Oh, yeah, okay. So, so you do know how to put that in words, though, right? So, what's the relationship between two? Ah, there you go, right, okay.
Would be 2/1.
Yeah, so you did it. You took the reciprocal, right? Okay. And then what did you do with the power? Ah, there you go, right, yeah. Yeah, that's words, right? Okay. Yeah. Did y'all get something? Do y'all remember that? You do? This is a hard one to remember. I'm not sure I remember. Ah, there we go, right. Okay. So how did you explain that?
So he basically put it the best way. He said the base goes to the denominator and the exponent becomes positive.
Ah, there you go. Yeah, that sounds good. All right. Did y'all get something?
No, I don't remember.
You don't remember that one? Okay. All right, we're getting ready to recall. Still don't remember it? Got stuck on zero still there? Okay. All right. We're gonna show you there. All right. Did y'all recall something there?
Like, doesn't it positive times? I mean, a negative times a positive. A negative times a negative equals a positive, correct?
That's multiplication, right? Okay. But in the power, is that something different?
It might be.
Might be. Okay. Yeah. Right. Okay.
Negative.
Yeah. Remember, people have already keep mistaking those powers as trying to turn those into products, right? Okay, and that didn't usually work out, right? Like 5 to the 0th was not 0 times 5, or 2 to the 5th was not 5 times 2. So here, when you're talking about multiplying, I'm thinking, I'm sure we may be going down a rabbit hole there. Okay, right? Whoops. All right. Okay, so that was, they're getting progressively tougher here. Who has what they think is the right answer? So instead of calling on someone, I'm going to ask someone to volunteer. So who seems confident of their answer there? What is it? Juan?
Yeah.
Juan. What do you think?
So I think it's.
Okay, wait. Let's hear what Juan has to say here. All right, so go ahead, Juan. Oh, I forgot. You get to introduce yourself here. So. Stand up, all right. So, Juan. So tell us your name.
Yeah, my name is Juan Ramirez.
Juan Ramirez, right? Okay, and your major is
Accounting.
Excellent, all right. And so we got lots of accounting majors in here, all right. So good. I'm going to teach you guys well. What's your favorite book, movie, or song?
Well, my favorite book is The Lord of the Rings.
Lord of the Rings. Okay, right. Okay, all-time favorite. What is your favorite food? Burgers, all right, okay, another big favorite, and I assume that's a note, so your favorite pastime is listening to music, or is it playing music? Sometimes it's playing. Oh, playing, all right, okay. Oh, you play guitar, great, okay, all right, so, all right, Juan, so now tell us what it means to raise a number to a negative whole number power.
Multiply itself 5 times over 2 to the 5th power, but because it's at 2 to the negative 5th power, that would be 2 divides itself 5 times.
So 2 divides itself 5 times? So how would you calculate that?
So that would be like, it's like you get the base number and you divide it by itself. Like
so this is 2 divided by 2. Divided by 2 again. Divided by 2 again. And then I need another one. Divided by another 2. Okay. What is that? What is that? What is that? When you calculate that, what do you get there? So we have 2 over 2. That's 1. Divided by 2 is 1/2. Divided by 2 is 1/4. Divided by 2 is 1/16. Yeah, 1/16. All right. One more time? Oh, you need another I thought I already had 5 2's here, though. Oh, but in your definition, I have to take the 2 and divide it 5 times. Is that what you're saying? No, I'm not trying to confuse you. I'm just wondering. One more time there? So I need another 2 here. So I would have here 5 2's. And then in addition to that original one. So this comes out to be not 1/16th, but 1/32nd. Yeah, okay. That's actually correct. All right. That's an interesting way of thinking about it. All right, Juan. Okay. But that's usually not the way we teach that. Okay. All right. Although your reasoning there is really good. Okay. That's actually correct. Who had another way of explaining this, though? You're going to get the same answer. I remember y'all had it there. What is
Take the reciprocal of the base, and you make the exponent positive.
okay, so it's what, Chris? Yeah. So Chris, what's your last name, Chris? Say that. Gin Tempo? Okay. All right. That will take me a while, probably. All right. So here's Chris. What's your major, Chris? Business management. Excellent. All right. Okay. So, Chris, say that again. You do what? You take the reciprocal. I forgot to put the minus sign here. So take the reciprocal of the base. So reciprocal means you just put 1 over that, right? Okay. So I would take 1/2 there. Right. That's the reciprocal of the base. And then do what? Make the exponent positive. So the minus 5 becomes positive 5. Okay? And when you and then you just have a number raised to a positive whole number power, which we already learned how to do, right? So that would be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Oops, I'm going to run out of room here. Times another 1/2 here. All right? And that works out to also be 1/32, okay? Oh, same thing, right? Which, by the way, is 1/2 to the 5th power, okay? Because 2 to the 5th power is 32, all right? Well, all right, so these are correct. Both of these, what Chris said and what Juan said, they work out the same, and they're both exactly right. So usually the easier way of thinking about raising a base to a negative whole number power, it's got to be a whole number still, is the way Chris said it. Take the reciprocal of the base, 1 over the base, and change the exponent to positive. Then you're back to having a positive exponent, and you know how that works, right? Okay, that's easier to remember how that works. Or you can also think of 2 to the minus 5 as just taking all that 2 to the minus 5 down to the denominator, and then just making the exponent positive. Either way will come out the same. All right, so here's what I always like to remember. Whenever you see a negative exponent, that means take the reciprocal. Take the reciprocal, okay? Negative exponent means take the reciprocal, okay? Do y'all recall seeing that? Okay, all right. So a to the minus m power, a to the minus m power is going to be, you can think of it 2 ways. 1 over a to the m power, that's how Chris suggested that you think of it, or it would be the same as 1 over a to the m power. Either one of those is the same. All right, but the key thing there is take the reciprocal, and then what do you do with the sign of the exponent? Make it positive, right? Just change that to plus, okay? So you can take that negative exponent, right, and you can make it plus really easily just by taking the reciprocal. And that's usually what we want to do immediately because, positive numbers are easier to work with than negative numbers, okay? All right, I got one more to quiz you about. This is the one that always blows everyone's mind, okay? This one's hard to think about, all right? So this causes an issue all the way through calculus for students. All right, we've only been talking about whole numbers like 1, 2, 3, or 0 is a whole number, or minus 1, minus 2, minus 3. Those are negative, but they're still whole numbers. Okay, what about a fractional power? Okay, it is possible to raise quantities to fractional powers, right? What does that, what possibly could that mean? So 9 to the 1/2 power, or 8 to the 1/3 power, or x to the 1, that's 1/4, x to the 1/4 power, what in the world could that possibly indicate? Okay, what could that possibly mean? So you remember about fractional exponents, especially the one you want to remember is 1/2, okay, because that's the one that occurs most often. What does it mean to raise a quantity to the 1/2 power? All right, so think and see if you can recall that, okay? And that will be our last rule. See if you can write that down in words, okay? What do fractional exponents mean? Do y'all recall this? Have y'all seen fractional exponents before? Yeah. You remember what it means? Okay. Anything ring a bell there? Yeah. Okay. Juan, do you remember what that means? Okay.
So if 1 would be like, or let's say like 2, to the 1/2 power.
Okay. Do y'all recall? No, nothing there. Okay, doesn't ring a bell at all. Did you ever see it before? Do you recall seeing it before? You recall seeing it, but well, that's good. Okay, so you know you've seen it, right? Okay, that means somewhere in your brain is the meaning of that. Okay, so what we have to do is sort of link on to that memory. Okay, see if you can dig that up. Okay, if not, we'll recreate that memory for you. Do y'all remember this? Okay. That sounds familiar there. Oh, that looks good. Okay. So y'all recall that, huh? I'm impressed. Do y'all remember that?
I'm not gonna lie. I've never seen that before.
You've never seen it before?
I see it on a test, but I don't think I got the answer.
Oh, you saw it on. Oh,
Yeah,
so you were supposed to
yeah,
know it.
on the entrance exam for like the TS.
Oh, you.
Yeah,
Oh,
for
you saw it
mathematics.
on entrance exam. I thought you said you
Yeah.
saw it on a prior test, but you couldn't remember it.
Oh, no.
You think you've never seen this before? I bet you have seen it
Yeah, I
before.
probably have.
Yeah. Okay. All right.
I haven't seen mathematics in a while.
Oh, in a while. I see. Okay. All right. Oh, okay. Do y'all recall what that means?
Yeah, doesn't it go like you square with the 1/2?
Oh, that sounds familiar. Okay. All right, so write that down for me there.
I'm trying to figure out. So would it be?
It's case by case.
Yeah. So like every single one would be a different way of doing it.
When you say
Depending on
every.
the denominator of the fraction.
Oh yeah, right. So 1/4 doesn't mean the same as 1/2 or 1/3. Yeah, right. Yeah, okay, right. Okay.
Root 4.
Yeah, root 4. There you go. Do y'all remember that? Have you seen it? Do you remember? If you remember seeing it, that's at least some progress, right? Do you recall seeing? Have you seen those before somewhere? Was it something that you had before but you never really learned, or seen it somewhere?
Like during sophomore year, but I don't remember.
Oh, but you don't recall there? Okay, that means that somewhere in your memory that's there. Okay, we just have to somehow attach to that. Do you ever remember seeing it before?
Yeah,
You do remember seeing it before? Oh, you weren't paying attention that time? Okay, well, all right, well, now we're going to learn it for good, right? Okay, this time we're going to be paying attention. Do y'all recall? Really far back? Yeah, but this is, don't worry, this exercise is really helpful, okay? So try to, like I said, squint and grit your teeth and remember everything you can, right? Okay, even if it's only, oh yeah, I remember seeing that in Miss So-and-so's class, or, oh yeah, I saw that in Miss So-and-so's class, but I really didn't ever pay attention to that, right? Okay, even those memories are helpful, okay? All right? All right, I heard a couple of, this is really hard, okay? I heard a couple of people mention, though, sort of the right thing, okay? Somebody sort of confident of what they think it means to raise a number to a fractional power like that. Ooh, I'm sorry, I didn't ask your name last time. You are Arthur? All right, Arthur Morgan. All right, what is your major? You're a business major also? Okay. All right, so Arthur, what does, for instance, 9 to the 1/2 power mean? What does 1/2 power tell you? Oh, so there's the key phrase there. Fractional exponent means what? A root, right, okay? Fractional exponents mean roots, okay? That's the phrase that you want to keep in your mind. Fractional exponents mean a root, and this is one that seems so not sort of intuitive, right? Okay, not easy to remember. So you really have to sort of practice this a lot to remember this. So 9 to the 1/2 power, you said that means what kind of root? Square root. Why did you say square root? Because it's based on this denominator, right? So that 2 tells you you're going to have a square root, right? Remember, when you have a square root, you don't have to put the 2 there, but you can if you want to. What is the square root of 9? 3, right, okay? So 9 to the 1/2 power, strangely enough, turns out to be 3, okay? That's what that means. So keeping that in mind, what about 8 to the 1/3 power? That also is a type of root. What type of root, though? Cube root, right. That's a cube root. And 8 also is a perfect cube. What is its cube root? 2, right, okay? You know that because 2 to the 3rd power is 8, right, okay? So the cube root of 8 is 2. What about x to the 1/4 power? That would mean what? Yeah, that's the 4th root of x, whatever x happens to be, right? So that denominator of that fraction tells you the type of root you're working with. So this is the one that occurs way more frequently than all the others, okay? That's 1/2 power. Remember, that refers to square root, all right? So if you have a to the 1/n power, right? 1/2, 1/3, 1/4, right? That means the nth root of a, okay? Just as Arthur said, the denominator of that fraction tells you the type of root. But fractional exponents are going to mean roots, okay? Yeah. The number that you do what now with?
So like you see how we brought out the 3, like the cube where it's placed. What is that called? Like I know you say outside, but
Oh, this one?
yeah.
That's called the index. That's its official name. Okay. But you can think of it as the type of root.
Okay.
All right. Index is the technical term for that. Okay. All right, so, that was good. All right, so I was afraid nobody would get any of these, okay? So I'm glad we got some and got a chance to review. All right, so let me summarize all of these rules for you. I'm trying to find Arthur's card because Arthur has given us an answer already. Ah, there it is, okay. All right, so let me summarize these rules that we sort of wrote down for you. Okay, and these will be in the notes, all right? So, you don't have to always copy this. It is good to write it down, but you don't have to because these notes are posted, right, on the Blackboard page after class. All right, so here are in math, not in words, but in mathematical expressions, the rules for simplifying whole number and fractional exponents. So these are just what we just learned. So if you raise a to a whole number power, that means you get m factors of a, right? If you raise a to the 0th power, you always get 1, but the base cannot be 0. If you raise a to a negative whole number power, you take the reciprocal, right? You take the reciprocal, but the base cannot be 0 again because that's going to end up with, you're going to be dividing by 0. So base cannot be 0 here. If you have the base raised to a fraction like this, where the numerator of the fraction is 1, that just gives you a root, okay? And the denominator of the fraction tells you the type of root. Here's a little bit different case. Suppose your fraction has the numerator not 1, all right? So what if you had, for instance, 9 to the 3/2 power, okay? or 2 to the 3/4 power. Okay, what does that mean? Well, the base there still tells you the type of root, still tells you the index of the root. The m, though, the numerator of the fraction, just keep that as an exponent. Just keep that as an exponent. All right, so keep the top of the fraction as an exponent, and the bottom tells you the type of root. By the way, the exponent, you can put that inside or outside the radical. So you can put the m under the square root. This is called a radical, remember, all right, or a root symbol. So you can put the m under the root symbol, or you can put it outside of the root symbol. Either way is okay, all right? Those are our 5 rules for simplifying exponents, and we run into exponents a lot in this class and in any algebra or math class, so it's really important that you be able to simplify those, okay? It's not hard once you've practiced with the rules a little bit. You'll remember them really easily. Well, let's practice a little bit then, okay? All right, so with your partner again, okay, with your partner again, we're going to do some of these, okay? Let's start with the easy ones first before we try to answer. So let's go up to here. So with your partner, just try to simplify those 4 expressions, A, B, C, and D there. 10 to the 0th power, minus 10 to the 0th power, 10 to the minus 1, 3 to the minus 2, okay? So that'll just take a minute or so to do that. So just write those down. And then we'll share some of our answers there, okay? So just based on those rules, I can't show you the rules at the same time, so sorry about that. So you just have to remember them as best you can. What we just talked about. So 10 to the 0th, minus 10 to the 0th, 10 to the minus 1, 3 to the minus 2. We'll get to the other ones later. If you want to work ahead, that's fine, but we'll get to those in a second. So hopefully these will go really fast. Because I kind of want them to be sort of eventually, maybe not immediately, but kind of sort of just like second nature to you. When you see one of these, you'll just automatically say, oh yeah, I know what to do with that, right? Okay, I know how to simplify that, okay? Take the reciprocal. Take the reciprocal. Always remember, take the reciprocal. Ah. Okay, let's see what we got there. All right. So I'm going to call a name again and get some answers. And your partner can help you, right? Okay. So you're not on your own. All right. In this class, you're not alone, except when you take the test. All right. All right. So Leslie, is Leslie here? Leslie Rangel? Oh, Leslie. I'm sorry, Leslie. Okay. All right, Leslie. So what about A? What is that one? So 10 to the 0th power. 1, right, yeah, all right. So that one is so automatic there, right? Okay. Raise a number to the 0th power, you get 1. What about minus 10 to the 0th power? 1. good try. And there's a little bit of a complication here, though, and that's the minus sign, right? Okay? And so the question becomes, the question that's key here is, do you take 10 to the 0th power first and then put the minus sign on, or is it the whole number minus 10 raised to the 0th power? Okay, that's an issue of what's called order of operations. In which order do we apply mathematical operations? Okay, and this is one that I put in as a trick question. All right, because it's easy to get messed up on this one. In general, what you're going to do is, Leslie, you're going to do the exponent first, and then the sign comes second. So here what you would do is first calculate 10 to the 0th power, which you already told me was what? 1. And then you apply the minus sign. So you end up getting minus 1 out of this. The minus sign stays, yeah, okay? Because the exponent will happen before the minus sign, all right? Exponents come before addition and subtraction in the order of operations, okay? I forgot to go back over the order of operations, so we may have to talk about that next time. Leslie, if you did it this way, your answer would be correct. So if the minus was in parentheses, that would be negative 10 raised to the 0th power, and any number raised to the 0th power is 1. So this would have come out as 1. Do you see the difference there? Yeah, okay? It's when you apply the minus sign, before the exponent or after the exponent, okay? So that's a very common mistake. So I put it in there for that reason. All right, so let's see, what about 10 to the minus 1? 1 over 10 to the first power. Perfect, right, okay? So, yeah, take the reciprocal, right, take the reciprocal. Of course, 10 to the first power is just 10, so you get 1/10, right, okay? Finally, Leslie, one more. What about 3 to the minus 2 power? 1 over 3 to the 2. And what is 3 squared? What's 3 times 3? 9. So you just get 1/9, right, okay? So Leslie, also, wow, we have so many accounting majors, okay? That's wonderful. And TV, and you like chicken wings, all right, okay? Hey, yay, all right. Y'all making me hungry. It's lunchtime, right? All right, so let's see. This is 1 over 3 squared, which is 1 over 9, okay? That's 1 over 9. Perfect. All right, let's try the next 4. Those are a little bit tougher, right? Okay, but not too bad. So try those quickly. See if you can get those. And then we just have 4 more and we'll be done, okay? So try those. 5 to the minus 3, 16 to the 1/2, 27 to the 1/3, and then 32 to the 1/5. So 5 to the minus 3, 16 to the 1/2, 27 to the 1/3. Sounds like it should be 9, but I don't think it is. And then 32 to the 1/5 power. Okay. What now? Yeah, that's 1/5, yeah. It's hard to read my handwriting sometimes. Yeah, that line. Okay, do y'all have something there? Is that enough time to simplify those? Let's try someone. Ben. All right, Ben. So tell us what you got here. So 5 to the minus 3. What is that? 1 over 125. Where did the 125 come from? Right. Yeah, so 5 to the minus 3 is 1 over 5 cubed. Always take the reciprocal, and then it so happens when you raise 5 to the third power, you get 125, right? Okay, so Ben, what about 16 to the 1/2 power? Square root of 16, right. Yeah, if you don't remember anything else about the fractional exponents, the one thing that you really have to remember is 1/2 power means square root, because that's the one that shows up most frequently, okay? And what is the square root of 16, of course? 4. Yeah, 16 is a perfect square, so we can extract its square root, and we get 4 out of that. All right, Ben, this one's also easy. What's 27 to the 1/3 power? Yeah, cube root of 27, right? So what is the cube root of 27? 3, right. We know that because if you raise 3 to the 3rd power, you get 27, okay? And then 32 to the 1/5 power? Yeah, 5th root of 32, right? Okay, or root 5 of 32. You can say that a couple of ways. And what is that? 2, yeah, okay. The 5th root of 32 turns out to be 2 because I think we saw in previous example, right, 2 to the 5th power is 32, right, okay. All right, we're going to save the last 4. Those are the hard ones, right, okay, because those have bigger fractions and negative fractions, right. So we'll save those to start next time so we can recall all of our rules, all right. I forgot to tell you about the homework, okay. I forgot to tell you about the homework, but you have a sheet, okay? You have a sheet somewhere that explains how to enroll in our online homework course, right? Okay? And so I think if you follow these instructions, you can get enrolled, okay? And I think I've already got homework posted already, okay? But we will start with looking at that also next time. So try to get enrolled. Now, there is a cost, of course, for enrolling in the homework. It's what's in the syllabus, so it's about $66, I think. But you do not have to buy a textbook because the textbook is embedded in the online course. All right, so that's why I did not show you a textbook today. Our textbook is part of the online course. There's an e-textbook there. So your cost will be for a book and whatever total for the class will be whatever's listed in the syllabus there, which is $66. But you get 2 weeks grace period. So you can go ahead and sign up and enroll now and start working on your homework. You don't have to have the cash available, the money for the yet, all right? So go ahead and enroll. Go ahead and get started, okay? So it's good if you go ahead and enroll so that we can talk about, what happened next time, right, okay, when you try to enroll. So those instructions are right here. Oh, one thing I want to tell you, if you have a My Math Lab, okay, this is My Math Lab, Pearson. So if you have a Pearson account, My Math Lab account, your username and password, you can still use that same username and password if you recall what that is. If you're registering for My Math Lab for the first time, of course, you'll have to create that. Use email address that you read. It does not have to be Gator Mail. Use an email address that you look at. So for instance, the one that's attached to your phone, okay, that's attached to the email on your phone, use that one. But if you want to use Gator Mail, that's great. But you do not have to use your Gator Mail account, okay? Read one that you read because I'm going to be sending you messages through that email, okay? So I want you to get those messages. So remember that. Use email that you read as the email for this site, all right? Okay. All right. So we're just slightly early today. That's fine. Okay. Normally we go to 1:15, but we didn't take a break today, so we went straight through. So we're doing okay. And I'll see you on Wednesday, right? Okay. Just leave your cards here. All right. Great first day. Y'all did really good.